So we have a 2 kilogram block placed on a smooth plane, incline, horizontal angle of 15 degrees. Draw the free body diagram. If I'm on an inclined plane, in all technicality, this is my box. The free body diagram is just the object with the force arrows. What two real forces do I have? Right. Gravity and normal force. That's the only two right now. If there's friction, we would add friction, but that's not true. In a lot of answer keys, I see people drawing the slant and then saying that this is the angle of 15 degrees. What's more important than that, though, is that we say that we have gravity and we say that we have the normal force. That's where you'll get your points from. Okay? Do they the answer keys for these always have, do they have the appropriate arrow labeled this, and do they have the appropriate arrow labeled that? So this would be like worth 2 points, and you'd be having to have the force of gravity and its label, the force normal and its label. That's it. Honestly, on the AP test, as far as any other physics professor goes, you will need to make sure that you have nothing but the proper arrows, and that goes for my tests as well. So if I have extra arrows, I'm going to be counting off. Okay? So that's probably more important than the AP test right now. Okay? Solve for the following. The weight force due to gravity equals what? It's a field force. Nothing affects it, so it's just besides gravity and mass, we have 2 times 9.8, 19.6 newtons. That's it. Normal force. Now, I know some of you are smart and we've gone through all the work for this. Many of you will say, I know that the normal force, Mr. Kwan, we went through it, is mg cosine theta. This would not earn you full credit. If you say mg full cosine theta is 2 times 9.8, and I get it, you're trying your best to show your work. Cosine 15. If you write down this as your work, you would still need to tell me where this came from. That the normal force, that the force in the y direction equals 0. And that the force in the y direction also is made up of, we look at our picture, every up and down arrow that we're worried about going off of this object. So what are we worried about up and down wise in our picture? Force normal and the proportion of gravity that is into the ramp, right? If you have at least these 2 steps, you'd get credit. There's one thing missing that we would probably call this 0 and then move it to the other side, which is force normal equals mg cosine theta. That's the next step, right? If this equals 0, we can say this. That's how you would earn credit on the AP test. 2 times 9.8, and that's 19.6. Cosine 15.
18.9.
Yeah. 18.9. I agree because it's mostly in the x direction. Sorry, it's mostly in the cosine. And the number's only 15. Net force. Net force. No, there is a net force. The net force is how it moves down the ramp, right?
Yeah.
So down the face of the ramp. So the net force equals mg sine theta. Remember, it's the remaining leg. When gravity is the hypotenuse and normal is one of the legs, this is the remainder. What's left over? Or what's the resultant after we've added the 2 technically? So mg sine theta would be 2 times 9.8 sine 15. I got 5. 5 point. Yeah, 5.07 or 5.1. What units is this? Newtons. Okay. So what's how do I find acceleration then? This is how it actually moves. With a force of 5.07, that's the net force. So the net force equals, guys, Newton's second law. Yeah, MA, mass times acceleration. Good. So this is how it will actually move. How does it accelerate down the plane? Via its net force. All the sums of all the forces, even if it's at any push or pull, we're going to use the net force, and we're going to divide by the mass, right? So it's just 5.07 divided by 2. That's probably like 2.5. Meters per second squared. And the distance traveled by the block if it took 1.5 seconds to reach the bottom after it was released from rest. Wait, this doesn't sound like a force problem at all, Mr. Kwan. What kind of problem is this then? Kinematics, right? So this is about the how does it move, no longer about the why does it move. The how it moves, we have the distance that we're looking for. We have the time that it gives us. What were our other hidden givens? We have the acceleration from the last part of the problem. And one more hidden given. It starts from rest. So we have all of these. What equation are you going to pick out to find x? X equals... Right. And if you don't have those 3 equations memorized by now, we're behind if you don't have it memorized. VI is 0. 1/2. Not 9.8. Whoa. What is my acceleration? Right. 2.54. That looks like a decimal. That's not a decimal. I already have a decimal. That was just an accidental pen touch. 2.54 square t squared? 1.5 squared? What'd y'all end up getting?
2.85 or 86.
Yep. 2.86 watts. Meters. It's just how far did it go? X equals, right? The block of mass M is placed on a smooth board length L. Draw the free body diagram. What 2 arrows do I need? Gravity. Force normal. And what's the other thing to make sure that I get my points? Yeah. This one didn't say to label, but, you know, that's how it'll be on the AP test, pretty sure. You're probably going to want to label those. You know, that would be smart of me. I'm just like on autopilot, sorry. Force due to gravity. Force normal. Thank you for figuring that out. Is it better now? Please tell me yes. Yeah? Okay, good. Okay. What's the weight force equal to? Fg equals mg. That's improper, Mr. Kwan. You need to solve using the given variables and the fundamental constants. Okay, so instead of Fg, what do I have to write for the weight? It tells me to write W. And what else do I need to know? The next one is M. What am I going to use? Can I use little m? It gave me big capital M, so I'm going to give back capital M. Okay? What about G? You're right in saying that it's a fundamental constant. Okay? So we're allowed to leave that as G because here on Earth it would be 9.8. If we somehow were Martians and we were doing this on Mars, it'd be like 3.7-ish or 3.6-ish, whatever it is. On the moon, it would be 1.6, and so it hasn't told us enough to actually use 9.8. But if we knew it was on Earth, then we could. All right, normal force. You want to gravitate towards the normal force equals mg cosine theta. And that's almost true. What letters do I have to use? N equals big M G cosine theta. Not just that, but remember, we said show your work. So the normal force, is that a vertical or a horizontal issue? Right, it goes off the ramp, so into the sky. So force, the net force in the x direction equals, net force in the y direction equals 0. And the net force in the y direction is made up of the stuff in our picture. So this is in our picture. Force normal. And the opposite is like it. Mg cosine theta. I just ran out of space. And so if this is 0, I can say 0 equals force normal. And then I'm going to add mg cosine theta to both sides. Acceleration? Wait, how do we do acceleration? Yeah. F, or net force, equals ma. And also we know that the net force equals mg sine theta. And so if these are set equal to each other, if I say mg sine theta equals ma, what cancels out? M. Okay, so it doesn't matter if I use capital M, lowercase m, that the acceleration equals g sine theta. Is that answer in given variables and fundamental constants? G? Am I allowed to use G?
Yeah.
That's a fundamental constant. Sine theta is just the angle that they're going to give us. A. What about A?
You have to add the
AP. So it's A of the plane. Yeah.
Do we not have to show the work like we did for mg cosine theta?
I think we took this and we set them equal to each other and canceled out the m. What do you mean by show work? We could say that the net force in the y direction, in the x direction equals the net force in the x direction. I don't know what else to say about that one to help us solve it. One, we're using F equals ma, right? That's the Newton's law. Two, we're looking at our picture and pulling what makes up the off the face of the ramp, along the face of the ramp variables. Anything that goes down the ramp or up the ramp, that's what would go here in this part. But we only have one thing that goes down the face of the ramp. Final velocity of the block after it's released, VF. I would not use the x equals VIT plus 1/2 AT squared equation because we use that because we have time. This one, did they give us time? Well, what did they give us that we haven't used yet, by the way? Okay, velocity initial. What else did they give us that we haven't used yet? Length, L. So I bet you I need the distance that it runs, or length L, in my equation instead of time. Just find velocity final. What equation is that? Two AX. Okay. What are we going to substitute in? What's VI? What's, well, 2 is just 2. What's A?
AP.
We can't use AP. It's not a given variable or a fundamental constant. It's something that we had to solve for. What is AP?
G sine theta.
G sine theta. We can use that. And then lastly, instead of X, L. So VF squared equals 2 G sine theta L. To clean that up, I'm going to say that VF equals the square root of 2 GL sine theta. I just like my theta being last because it's going to be a larger function. Less parentheses to handle in my old calculators. If they give you these 3 variables, could you go back and solve for the actual value? Probably. You just plug it in each case. All right. So the original, when I say the original, the 2014 AP test started off with like a box on a ramp and left it in letters and had certain things and fractions of each other that kind of canceled out. And if you tried to use numbers, you probably wouldn't have figured out that some of the letters just disappear, go away, get canceled out. Is there a mass in here? No. Okay? And so in our case, mass does not matter. And so sometimes it's actually better to leave it in variables because once those variables appear on the top and the bottom, they've canceled out. Or if it's anything like that, it kind of just, maybe it gets squared and it goes away and you deal with it a different way. Okay? So a lot of times physicists will leave things as their letters. That's all I have for today.